Right now, a sensor smaller than an AA battery could be stealing 20% of your power and costing you an extra $30 every fill-up. No warning light, no error code, just slow, silent performance loss. Shops see it constantly. They replace spark plugs, coils, even fuel pumps. Hundreds of dollars wasted. Then someone finally cleans one sensor nobody thinks about. 5 minutes later, the car drives like new. We're covering the dirtiest sensors in your engine, but the worst one, the one rarely cleaned, comes at the end. Let's start with number 13. Sensor number 13. MAF sensor number 13. The mass airflow sensor. This component sits right in your intake tube, measuring every molecule of air entering the engine. Inside, there's a heated wire about as thick as a strand of spider silk, and air flowing past it pulls heat away. Your computer measures how much electricity it takes to keep that wire hot, and that number tells it exactly how much air is going in. More air, more fuel. Perfect balance. Here's the problem. That wire is exposed to everything. Road dust, oil vapor from your crankcase, debris from cheap air filters. Over time, a microscopic film builds up on the wire, and suddenly the temperature readings go wrong. The computer thinks there's more or less air than reality, so it delivers the wrong amount of fuel. You'll feel it as rough acceleration, fuel economy dropping 3 to 5 miles per gallon, idle that hunts up and down randomly. Some cars even stall at red lights. Shops charge $60 to $80 to spray it with MAF cleaner. It takes 3 minutes. But there's another way engines measure air that works completely differently. Sensor number 12. MAP sensor number 12. The manifold absolute pressure sensor. Instead of measuring airflow directly, this one reads vacuum inside your intake manifold. It's a pressure-sensitive chip that changes resistance when vacuum pulls on it. Closed throttle at idle creates high vacuum. Wide open throttle drops vacuum to almost nothing. Your computer combines that pressure reading with RPM and temperature to calculate air mass using physics. The sensor itself rarely dies. What kills it is the vacuum line feeding it. One cracked hose, one loose fitting, and the readings go completely sideways. The computer thinks you're under heavy load when you're barely touching the gas. Result? Fuel mixture goes insanely rich. Black smoke out the exhaust. Fuel consumption jumps 30 to 40% overnight. Check engine lights screaming lean or rich codes. Shops will sell you a new sensor for $70 to $90 when all you needed was a $5 vacuum hose. Clean the sensor port, replace the line, problem solved. Now let's talk about the sensor that directly watches your combustion quality. Sensor number 11. Oxygen sensor number 11. The oxygen sensor. Mounted in your exhaust pipe, this is your engine's quality control inspector. It's a ceramic element that gets heated to over 600 degrees and generates voltage based on oxygen content in the exhaust. Perfect combustion at the ideal 14.7 to 1 air-fuel ratio produces about half a volt. Too much oxygen means lean, voltage drops. Too little oxygen means rich, voltage climbs. The computer adjusts fuel injection thousands of times per minute based on this signal. When the sensor gets contaminated by bad gas, oil burning from worn rings, or cheap fuel additives, it doesn't stop working. It just gets slow. Delayed reactions, lazy voltage swings. The computer can't keep up, so you get this seesaw between rich and lean. Power drops, fuel economy tanks, emissions test, guaranteed fail. Replacement runs 120 to 200 depending on how many your car has. Most engines have 2 to 4. But cleaning sometimes works if contamination is light. There's one more sensor that tells the computer what you're asking for. Sensor number 10, TPS number 10, throttle positions. Sensor. This little potentiometer bolts right to your throttle shaft and tracks exactly how far you've opened the gas pedal. Inside is a circular resistive track with a contact that slides along it as the throttle moves. Closed throttle sends about half a volt to the computer. Wide open sends close to 5 volts. That voltage tells the computer whether you want smooth cruising or maximum acceleration, and it adjusts fuel and timing accordingly. The problem starts when that resistive track wears out at the positions you use most. Highway cruising speed. Stop and go traffic idle. The contact hits those worn spots and the voltage suddenly drops out or spikes randomly. From your seat, it feels like hesitation, jerking, or complete power loss at very specific pedal positions. Some cars just shut off when the throttle passes through the dead zone. Replacement costs $100 to $160 installed. Before replacing it, good technicians check voltage on a scan tool while slowly opening the throttle, watching for sudden drops that prove internal wear. Now we need to talk about the sensor that keeps your engine timing perfect. Sensor number 9, crankshaft position. Sensor number 9, crankshaft position sensor. Without this sensor, your engine is completely deaf. It's mounted within millimeters of your flywheel or a toothed wheel on the crank, and it reads magnetic pulses every time those teeth spin past. Each pulse tells the computer exactly where every piston is and how fast the engine's turning. That information controls fuel injection timing and spark timing with millisecond precision. When this sensor gets coated with metal shavings, burnt oil, or road grime, the magnetic signal weakens and starts cutting out. You'll get random stalling when the engine's hot, long cranking before it starts, or the engine just dies while you're driving with zero warning. Shops immediately blame the fuel pump or ignition system and start throwing parts at it. $400, $600. Later, nothing's fixed. Then someone pulls the sensor, wipes off the metal debris with a rag and some contact cleaner, reinstalls it. Engine fires instantly. Problem gone, but knowing crank position alone isn't enough. The computer also needs to know where the camshaft is. Sensor number 8, camshaft position. This works in tandem with the crank sensor like two synchronized watches. The crank sensor tells the computer engine speed and position. The cam sensor reveals which stroke each cylinder is on, intake or exhaust. That lets the computer fire each injector in perfect sequence and control variable valve timing systems. It's usually mounted in the timing cover or valve cover, reading a trigger on the camshaft itself. When oil sludge, thick contamination, or internal cracks mess with this sensor, the computer loses that precise cylinder reference and drops into limp mode. Sequential injection gets abandoned. The computer just batch fires all the injectors together. Idle gets rough. Cold starts take forever. You'll notice hesitation between 2,000 and 3,000 RPM that shops blame on coils or injectors. They'll sell you a coil pack for $150, $200. Real fix? Pull the cam sensor, clean the reading surface, check the connector. 5 minutes. Engine smooths right out. But there are sensors even more ignored because they're so small you forget they exist. Sensor number 7, intake air temperature. This tiny thermistor screws into your intake manifold or air duct so small most drivers never notice it. Its only job is measuring how hot or cold the incoming air is. Sounds simple, but it's critical. Cold air is denser, packed with more oxygen. Hot air is thin. The computer uses this data to fine-tune fuel delivery on every single combustion cycle. Over months and years, oil mist from the crankcase breather, sticky dust, and residue from oiled performance filters coat the sensor element. Once contaminated, it can't read true air temperature anymore. It reports artificially hot or cold readings, causing the engine to run constantly rich or lean. You lose power. Fuel economy drops 2 to 4 miles per gallon. In hot climates, you might even hear light pinging under load. Shops charge $40 to $70 to replace it. When cleaning with electronics, cleaner restores instant response. Total time? 2 minutes, but there's another temperature sensor controlling something even more critical, the temperature of the engine itself. Sensor number 6, engine coolant temperature. Sensor number 6, engine coolant temperature sensor. This sensor has more influence over how your engine runs than almost anything else, and most people never suspect it. It sits in the coolant passage telling the computer how cold or hot the engine actually is. During cold starts, the computer uses this reading to enrich the fuel mixture, raise idle, speed, and adjust timing. As the engine warms up, those cold start strategies fade away. When this sensor gets coated internally with corrosion, scale, or sludge from old degraded coolant, it starts lying. The computer might think the engine's still cold when it's fully warmed up, or hot when it's actually freezing. You'll burn fuel like crazy. Idle gets rough and unstable. Cold starts become impossible. Cooling fans run at the wrong times. Long-term engine wear from improper fueling starts adding up. Replacement costs $60 to $120 installed depending on location. But before replacing it, flush the cooling system. Old contaminated coolant is usually what kills these sensors. Fresh coolant, clean sensor. And yet there's still one sensor that causes expensive problems nobody ever cleans. Sensor number 5, vehicle speed. When your speedometer needle starts bouncing, your transmission makes bizarre shift decisions, or cruise control randomly shuts itself off. This is usually the culprit. The VSS mounts on the transmission or differential and generates electrical pulses based on how fast the output shaft or wheels are spinning. The computer converts those pulses into speed data that controls shifting points, fuel cutoff during deceleration, cruise control operation, and traction systems. When the sensor gets contaminated with transmission fluid, road grime, or metallic debris, those pulses arrive incomplete or irregular. The computer thinks you're going faster, slower, or completely stopped while you're still moving. Transmission starts hunting between gears. Shifts feel harsh or delayed. You're doing 60, but the speedometer shows 40 or jumps between 30 and 70. Shops diagnose bad transmission and quote you $1,500 to $3,000 for a rebuild. Real problem? Dirty speed sensor. Pull it, clean the magnetic tip, flush the connector with contact cleaner. 10 minutes. Shifting goes back to normal. Transmission's fine, but there's an even more critical sensor that listens inside your engine like a precision microphone. Sensor number 4, knock. Bolted directly to your engine block is what's essentially a high-tech listening device monitoring every explosion inside your cylinders. It's a piezoelectric sensor that detects specific vibration frequencies caused by detonation or abnormal combustion. When the sensor picks up knock from low-octane fuel, excessive heat, or aggressive timing, the computer reacts in milliseconds. It pulls ignition timing back and enriches the mixture slightly to protect the engine from damage. Here's where it gets dangerous. When the sensor gets coated with oil, corrosion, or dirt, or if it's installed with wrong torque, sensitivity drops. It can't accurately transmit those critical vibration signatures anymore. Two things happen. Either real detonation goes undetected and your engine operates on the edge of destruction, or false signals force the computer to constantly retard timing, killing power and making the car feel like it's towing a trailer. Replacement runs 100 to 220 depending on location. Before replacing, clean the mounting surface and connector, reinstall with proper torque spec. Engines that felt exhausted suddenly wake up. But some sensors don't protect. They only warn you when it's almost too late. Sensor number 3, oil pressure. That red oil light on your dash is one of the most terrifying warnings you can see, and behind it sits a small pressure sensor that gets almost zero attention until disaster strikes. This sensor threads into an oil passage in the block or cylinder head. Its job is simple, but life or death critical. Detect when oil pressure falls below safe levels. Inside, a pressure-sensitive diaphragm opens or closes a circuit, or in newer systems, sends a variable signal to the gauge. Over years of heat, cycles, and oil contamination, the sensor's inlet passage clogs with sludge, varnish from burnt oil, and debris. That blockage prevents actual oil pressure from reaching the sensing element. Now you've got a nightmare scenario. Your engine might be running with dangerously low pressure while the sensor says everything's fine. Or the opposite. False warnings because of slow, erratic response. Shops have documented engines showing perfect pressure on the dash, while an external mechanical gauge reveals critically low readings. By the time you find out, bearing damage is already happening. Replacement costs $30 to $70. But cleaning or replacing during oil changes can save you from a $5,000 engine rebuild. There's another seemingly innocent gauge that lies more than people realize. Sensor number 2, fuel level. The fuel gauge seems like a minor detail until your car dies on the freeway, showing a quarter tank remaining. Inside, your fuel tank, completely submerged and almost never inspected over the vehicle's entire life, is the fuel level sender. It's a mechanical float attached to an arm that slides across a variable resistor. As fuel level rises and falls, resistance changes, and the gauge or computer converts that into the reading you see. After years of exposure, the resistive contacts oxidize, varnish from low-quality fuel builds up, and contamination creates false dead spots where the arm can't make proper contact. The gauge bounces around randomly, gets stuck at half tank, responds super slowly after refueling, or worst case, shows fuel when the tank is nearly empty. You think you've got 50 miles of range, you've got 5. Engine starves for fuel and dies. Fuel pump runs dry and burns out. Now you're looking at $400 to $700 for pump replacement plus towing. Many complaints about bad fuel economy actually start here. A lying fuel gauge makes you think you're getting worse mileage than reality, or better, until you're stranded. But none of these sensors matter if the connection between them is failing. Sensor number 1, sensor connectors and wiring. The most common sensor problem isn't a failed sensor at all. It's the connectors and wiring harness feeding it. Every sensor in your engine bay depends on 3 things: clean power supply, solid ground connection, and an uninterrupted signal path back to the computer. In millions of aging vehicles right now, vibration, moisture, engine heat, and minor impacts are slowly destroying wiring, pins, and connector terminals. Green corrosion forms inside connectors. Intermittent contact develops. Wires break internally while the insulation looks perfect. Ground points loosen and make contact only when they feel like it. The scan tool throws codes for temperature sensors, oxygen sensors, position sensors, pressure sensors. Shops replace them. $200, $300, $400. The problem comes back a week later, because the real issue is that moving the harness makes the fault appear and disappear. The sensor was fine. The path carrying its signal was destroyed. What drivers never see is that cleaning connectors with dielectric spray, fixing ground points, repairing poor splices, and properly securing the harness eliminates ghost failures. That's why experienced mechanics always check wiring and connectors first. Very often, the problem isn't the $100 component. It's the $2 connection that nobody thought to clean. So before you let a shop sell you sensors you don't need, check the basics first. Clean connections, tight grounds, proper wiring. Most of these problems cost $10 and 15 minutes to fix. If this saved you from an expensive misdiagnosis, drop a comment with which sensor you've dealt with.